Okay, it looks like everybody has joined for the most part. Before we get started with the presentation, if at any point during the slideshow you have any questions, feel free to type it in the chat and I will try my best to address them at the end. After the webinar has concluded, all participants will be emailed a recording of the webinar as well as a link to the application note that goes along with the presentation. So now I'm just going to introduce myself, introduce the presenter and the topic of this webinar. My name is Trinity Pham. I'm the marketing coordinator at TC Communications, and our presenter today is Steve Craig, VP of Sales and Marketing, and today he will be discussing 2 customer examples of staying NERC CIP compliant when connecting third-party facilities.
All right, thank you, Trinity. Well, today what we're going to be talking about is something that we've seen in a variety of cases over the last few years, and that is where third-party generation, often solar and wind farms, are being connected to an existing utility, and there's a desire to pass metering data backwards and forwards between the two. And the question becomes how to do that, and to do that in a way that stays NERC CIP compliant and normally in a simple fashion. So here we have the stylized diagram here, utility on the left and third-party generation with the meters on the right. And of course, the easiest way using modern meters would be IP connectivity. And most of the meters are IP capable. Utility has an IP network, and so connecting the two would be relatively simple. However, when you do that, there's a significant issue with NERC CIP compliance. And so most utilities have chosen not to open their network up to third-party metering and to an alternate network. So what they do, there's a couple of solutions that we've seen fairly commonly. There have been some others, but these are probably the most common that we see. And the first one is using phone or leased lines between the two. And they use the phone lines, still relatively easy to get hold of. And what that means is when you connect using a phone line, no issues here with NERC CIP compliance, because as you can see, there's no connectivity between any IP networks at either end. The phone line prevents that, provides a point of isolation between both sides. Now, obviously, to do that easily, potentially you need a phone line for each meter and be able to call them up. Well, that's not very efficient. Each of these phone lines do cost monthly fees, and there's not a great deal of data being passed backwards and forwards with just the metering data. So it's very common that they use a substation line sharing switch, or the acronym an SLSS. And for those of you who are not familiar with that, I'll show you here. So you have a polling computer with a modem, a phone line going through the PSTN network, goes out to the SLSS, and what the SLSS provides is a means to share that single phone line between a number of remote devices, in this case, meters. So you can see the first one. Typically what happens is the polling computer instructs the modem to call the SLSS. Once the SLSS picks up, it provides a dial tone, and then you just use simple over dialing to call device 1 and so on. Following that, they will then poll through to device 2 and so on, typically sequentially, but there's no need. You can do it in any order you would like. The SLSS simply provides the means to connect a single phone line to multiple devices. Now that's all well and good. The original manufacturers of SLSS have long since ceased making such a device. And so people have come to us and said, do you have an alternative? And we do. And the alternative we provide here is TC3848-1. Now, this is part of our jumbo switch line. It comes with 5 ports, a single FXO port that will be connecting to the line, and I'll show you how to connect it later on, and 4 FXS ports. So in its simplest form, it comes in a standalone unit such as this. You would just simply connect the phone line from the PSTN to the FXO port, and then use the 4 FXS ports to connect to the relevant meters. If you need to use if you want more than 4 meters to be polled, you simply parallel up these cards. I've shown here how you can do that with two cards to provide 8 ports. Now you'll see that it does have, in that case, 2 FXO ports. You can use both. However, most customers simply use a single phone line into one of the cards, and then from that phone line you can connect to all of the FXS ports. And I'll show you how that's done. This example was actually done using a customer for ours in New Mexico. They were looking for an alternative to the SLSS. So in this case, we simply add the TC3848-1. Now, I've put here that it actually has an inbuilt virtual PBX. What that allows you to do is to work exactly the way I described the SLSS before, whereby the polling computer instructs the modem calls the 3848-1, picks up, provides a dial tone, and then the modem overdials to any of those meters. And that's a really simple way of setting it up. It's very easy using the graphical user interface of the 3848-1 to set that up, and provides essentially a drop-in replacement for SLSS ones or for new facilities. If you want to add additional ports, you simply add the 3848-1. These connect to each other using Ethernet, so they can just be daisy chained together using Ethernet. You can actually add up to at least 7 units. You could put more in if you wanted, but at least 7 units to provide up to 28 ports for meters. As you can see, you use a single FXO port, as I mentioned before. Use a single FXO port, and the inbuilt virtual PBX is shared between all of the 3848-1s. So in that case, there is one virtual PBX or phone lookup table that is shared between all of them, and you can simply overdial and reach each of those meters. Now, doing that allows you to address each of the meters as though each of them was connected via a phone line. As you can see, there's no IP connectivity in this case. So really simple to do. However, we have been approached by some utilities who are using this capability and said, well, in the area that they were, it was impossible or difficult for them to actually get a lease line, or being more costly. And so they've looked for a solution here to replace this PSTN without running afoul again of NERC CIP. And we've got a couple of solutions for that. The first one is to utilize fiber optic cable. One of our customers used this. They used our phone simulation or extender, the TC1901 at each end, running fiber optics between the two. You can run either a single, dual fiber, single mode or multi-mode. And that simply goes in place of the PSTN in that fashion. Now, although you have replaced it with fiber, you can see that there is still a phone line at either end. And so there is no actual connectivity between the two. It's still connected via phone line. Another solution as well is to utilize a third-party IP solution. You could use the utility system if you wanted to, but in this case, what we're going to show is a third-party ISP or whatever to provide IP connectivity. And again, using a different product, in this case, the TC1910, we've again extended the phone line over a ISP internet IP network. And again, you've still got the same isolation between the two systems. There is no IP connectivity through the system that there would be by connecting the meters directly to the utility's IP system. So that's the SLSS, and that's a simple solution, a drop-in solution using essentially phone lines and direct dialing. Okay, we're now going to discuss our second case. This was from a utility in Idaho, and in this case they're using T1s rather than phone lines. Now T1s, while not as popular as they used to be, are still readily available. And again, because it's a T1, there's no IP connectivity between the two sites. However, of course, there is an issue, and the issue with this is that it's rare that the metering interface to a utility is to T1, and it's also extremely rare that, if not available, that the meters themselves have a T1 interface as well. And so once again, in this case, we're going to introduce one of our products. This is the part of our jumbo bank range, the TC8631. This provides 4 ports of RS-232 or 422/485. You could choose which you would like. It's a high-speed device, and it's connected via T1. Should you wish to add additional ports, you can daisy chain them, as I've shown in this diagram as well. And you can see that you just go from one unit to the other. They put the serial on different slots of the T1 and communicate back to the central site. I'll show you the overall scheme later on. Also, because of the way we've done this, you can also utilize redundant T1s as well. So because if you're using 8 ports in this fashion, you can not only daisy chain the two together, but you can actually utilize the 2 T1 lines so that the green T1 is the primary T1 and the purple T1 is the secondary one. Under normal circumstances, the communication will be over the primary T1. If for some reason there is a problem with the primary T1, then communication will seamlessly move over to the secondary T1. And this is the application for this. I've shown 8 ports at each end. Meters connected via serial ports on the right, and on the left is the SCADA computer. And again, just simply connected via a T1. And that's a simple solution, assuming that T1s are available from your provider. This makes a very easy way of doing connectivity. If you wanted to do a similar one to the one that was done before with phone lines and so on, we have a variety of products, but in this case, the customer was looking to use serial communication between their meters. On top of that, although I mentioned that T1s are available, some customers do find T1s a little bit more hard to come by. Again, they're becoming a little bit more hard to come by, but also becoming a bit more expensive. And so in this case, there is one customer approached us and looked to maintain the isolation of the T1 while again using a Ethernet connectivity, probably through an ISP, and utilizing two of our jumbo switch products, the TC3845-1. So basically what we've got here is we have meters connected via serial being converted to T1, the T1 being converted to Ethernet, back to T1, and then back to RS-232 or serial, whichever serial you chose. This again gives you an isolation point between the two networks at the T1 point. In this case, we also provided one other addition as well, and there is a write-up about this as well. Normally our jumbo switch products are connected using IP addresses for the devices. They asked again to eliminate any need to go through any NERC CIP compliance to look for this to be connected using MAC addresses. So we are in the process of rolling out to all our jumbo switch products the capability to not just use IP addresses, but if you prefer to utilize MAC addresses for this purpose to ensure a little bit greater security and to not require NERC CIP compliance. So that's just another example of the second case of what we've done. And then in summary here, what we've shown, two cases, the first one using phone, the second one using T1 to connect the systems together with the desire or with the aim of not connecting the two systems together directly using IP. The reason not to use IP was to remain NERC CIP compliant, or at least to save you having to go through that exercise. This simplifies it a great deal. And as you can see, a very simple drop-in replacement for this for these solutions. And I think what we've also aimed to show here, I mean, I do work for TC Communications, is to show our flexibility. So you can see that there's a number of solutions here. I could go on with some other suggested solutions to do that. But the idea of these two cases was to show both a great deal of flexibility and the ability to work with a customer to address their particular needs. If you'd like to learn a little more about TC Communications, I suggest heading to our website, tccomm.com. This you'll see as the homepage. What you'll see there is the ability to not only look at our topics, our feature products, but also our resources such as video libraries, literature, news, etc. On that as well, you will be able to find our product matrix. Our product matrix for our products shows you down the left here the capability of the interfaces over the transporter across the top. If you find that on our website, that's available in electronic form. So once you actually take a look at that and identify the product you want, you can click through and choose the particular product, and it will take you directly to the product page where you can look at both the product and download datasheet, etc. If you're working in a substation environment, there is also a version, the IEEE 1613 solution guide, which shows you the products that have IEEE 1613 approval. Okay, that takes us to the end of our webinar. I want to thank you for your attendance, and Trinity, I'm not sure if we had any questions.
Yes, we have actually a few questions. The first question we have is, why do utilities still use phone lines?
Well, I think, as I mentioned before, in this case, it's being it was a simple means to provide that isolation. Generally speaking, phone lines are still available. In some places, they're not so available. But in a lot of places, they are freely available. I would say that what we are seeing is that Verizon and AT&T in particular are either eliminating their lease line, copper line service, or they are significantly increasing our prices. That's certainly true of friends at AT&T. Hence why we had the customer come back to us and say, hey, we want to connect using an SLSS, which uses a phone line, but do you have a solution for us where we don't actually have to go and pay a monthly recurring fee for the phone line? So that's the primary reason. There is still quite a lot of equipment that utilizes lease lines. Some of you will be familiar with analog two-way radio. We see a lot of it in there, but it is rapidly declining as the telcos have been freed from the legal requirement to provide that service.
Okay. This next question actually came up when you were talking about the TC8631. What baud rates for serial can TC Communications support?
Right. So for under the general baud rate is 38.4 kilobits per second. Under certain circumstances, that can be changed, can be increased to 64 kilobits per second. But I'll say, to be safe, in all cases, 38.4 kilobits per second.
Okay, just a couple more questions here. Where is your product made?
Okay, didn't normally would introduce TC Communications, didn't do that. So we are based out of Irvine, California. All of our product is both designed, manufactured, and supported out of Irvine, California. All of the products are manufactured in-house. And as I said, both manufactured, supported, and designed out of that facility.
Okay, last one I'm going to address here is somebody typed in the chat that they have a current project, a need. What distributors do you use?
Okay, so TC Communications typically sells direct. So if you do have a project, I'd encourage you to reach out to us. You can do that either by reaching out to me or one of our salespeople. All of that's available online. There's an online inquiry form if you could fill that out, or you're welcome to give us a call on the phone number on the screen.
Okay, that's all the questions that we had today. Thank you.
All right. Thank you very much for attending. I really appreciate it.